Okay, so let's start where we left off yesterday. I think we started with the sets. Okay, we understand the basic property of the sets. What is a set, right? And we mentioned strictly. Remember what was the set? Set is what? Unordered collection of unique elements, mean in which the order is not there. There is no particular order, and because order is not there, indexing is not supported. At the same time, it consists of only unique elements, right? And we say the property. How do we create the set? Okay, and then we solve few problems with the help of set only. Example, we take an example of a list of cricket students playing cricket, a list of students who are playing soccer, and we solve few problems with the help of union, and then we use intersection, right? Then we find symmetric difference, and also we find difference. Let's come across now. Suppose, let me create a set once again. Okay, suppose set is having elements 1 comma 2 comma 3 comma 4 comma 5. Okay, so I'm just creating a set for now, 1 comma 2 comma 3 comma 4 comma 5. So every class has some methods available. So this object has been created of the set class, right? And we can verify, for example, if I print type of S1, sorry, print the type of S1. It is what? It is belongs to the class set. Means what? It is an object of the set class. So every class will have some methods that they can perform. Okay, some methods will be there. So also set has also some method. And to know a method of any class is very simple. Go to the object of that class, okay, that you have created. Press a dot and press a tab. Okay, the moment you will press a tab, you will see all the methods which are available here. Okay, all the methods which are applicable to the particular class will appear here. So you don't have to memorize everything. You just press the tab and automatically all the methods which are available will appear here. Okay, so let's come one by one. So first method that we're going to take is add method. Okay, and what it does, don't memorize, just go inside. The name itself is saying it is going to do some addition. What addition? Okay, go inside and read what it says. Add an element to a set. Okay, it's add an element to the set. Means what happened? I have number 1, 2, 3, 4, 5. Suppose I want to add one more element on in this particular set. Okay, any particular element in this particular set. Suppose I pass here a 7. Okay, so this 7 will be added to this set S1. So if I execute this, okay, and check my S1 once again, see the 7 has been added. Okay, the 7 has been added. But now suppose if I try to add an element, okay, which is already present. Can anybody tell me what will happen if I try to add 7 once again? Will the 7 be added again to the S1? Everyone? Yes, please tell me.
No, sir.
Yes. Why? Reason?
Uh,
Yes, come on.
Duplicate elements can be
Yes. Very good. Because that means you are listening 100% with the proper attention, because duplicate elements are not permitted inside your set, right? So if I execute this, nothing will happen. Nothing will happen. If I can check my S1, again, it will be the same thing. Okay, and not mandatory that it is having 1, 2, 3, 4, 5, 7 numbers. So you can pass a number only. You can pass anything that you want to pass. Okay, for example, I want to pass A here. Okay, let me execute. It has been done. If I check A, my A will be there. Okay, and don't rely that it is adding at the end. Don't rely, because your sets does not have any particular order. So it may add at any place. So don't rely, okay, where it will be added. Don't rely on the same number. Okay. So let me move ahead. The one method is understood. Whenever you want to add an element, an individual element to a set, we can take the help of add method. Similarly, suppose we want to remove any particular element. Okay. So suppose I use s1 dot remove method is there. Okay. S1 dot remove. And always I advise, go inside and read the definition. What it says, removes an element from a set. Okay, removes an element from a set. It must be a member. That is very important, right? So whatever element you will pass here, that element should be the member. Means the element which you want to remove, you have to ensure that that is a part of this particular set. Okay, if there is a part of this particular set, that will be removed. But if it is not a part of that particular set, what it will do, see, if the element is not a member, okay, it will raise a key error. Okay, that means your program will crash. If you are using this statement anywhere inside your program, it will crash. Okay, so suppose I pass here again, I want to remove A only. So I just pass here A. So A will be removed without any problem. Okay, gone. If I check my S1 once again, my A will not be there, right? A has gone. But suppose I try to remove an element which is not there. S1 dot remove. Okay, and I use suppose 10. I mentioned here 10. Let me execute this. What I get? A key error. Okay, now an interview question comes. Okay, now an interview question comes. They say that you have to ensure that you have to use the remove method, but at the same time you have to ensure that your program should not crash, because you are going to work in a production environment, means in a where your entire server will be dependent on your coding. If anything happens, your entire server will crash. So you should ensure that this particular error should not occur, or your program should not crash. So what we should do in this case, remember, if anything is like that, what we can do, we can take the help of in and not in function. We can take the help of in and not in function. So if you want to remove this, and at the same time is I want to use the remove function, but at the same time I want to ensure that I will use the remove function only when, remember, I will use the remove function only when the particular element that I'm going to pass here is present inside my set. Only then. For that, remember, we have a function available in, oh sorry, in operator, right? So I can say if whatever element, what was the element? 10 in S1. Okay, and we know that what 10 in S1 will return. If 10 is present in S1, it will return true, otherwise it will return false. See, right now it is not present. So anything which returns true or false, we can pack it inside my if statement. So I can mention if 10 in S1 means if this condition is resulting true, only then use what? S1 dot remove 10. Now, if I execute this, your program will not crash, because you are going to execute this instruction only and only in this case if this particular condition is satisfied. So whatever element is there, if that element you will mention, instead of I'm hard coding here 10, but it may be anything like a variable, suppose x. Okay, x is maybe anything. Suppose x is equal to 10. It may be anybody's anything as well, right? It can be anything. Let me come again here. Yeah, now I think it's fine. So x is equal to 10. So instead of 10, I should pass x here, and I should check if x is equal to, if x is an S1, okay, then remove x. Means if this condition gets satisfied, means if this element is present in this, only then remove this. It may be like a case, right? There is some person who is leaving your organization, and your boss says, okay, remove his list from the name, his name from the list. Okay, example, I'm just giving an example. Okay, remove his name from the list, and you want to use using, you are using set theory. Example, just an example I'm giving. Okay, using set theory. In that particular scenario, what you should do, you know that the remove function that I'm going to use with the set may have a problem, that if that element is not present in the set, it will raise an error. Okay, and because of which my program is crashed. If that is the scenario, always check the presence of element in the set or anything that you are using, right? So ensure that how you can prevent your errors. So if I execute this time no problem will happen at all, right? But suppose S10 is not there, program has not crashed, but suppose it is, if it is even there, no problem. Suppose what is the S1 element? 1, 2, 3, 4, 5, 6, 7. If I pass here, just check everyone. We have in S1 1, 2, 3, 4, 5, 7. Okay, so let me pass 5 here. Okay, so this condition will be true, then this instruction will be executed, and now no problem. Okay, it will be removed without any problem. So if I check my S1, 5 would have been removed. Yes, check everyone. What is fine? Tell me, is it fine? How can we prevent the errors?
Yes, sir.
Okay, so remember, please. Yes, very good. Now move ahead. Similar to actually remove, there is one more function which is known as discard function. So I'm coming again to the S1 dot discard. Okay, what it does? Okay, see, remove an element from the set if it is a member. Okay, remove an element from the set if it is a member, and if the element is not a member, do nothing. If it is not a member, then do nothing. It will not do anything. Means it will not crash your program. Means again, it is used to remove the program, but it is a safer removal. You can say this way. It is a safer removal. It is a safer removal, right? So what internally it does, what internally it is doing, it is simply doing what? Whatever element I was passed here, okay? If that element is a member of the set, that element will be removed. If it is not the member, nothing will be done. Very much like the same scenario that we implemented here. Okay, very much like the same scenario that we implemented here. So if I pass here, see example 7, then 7 will be removed without any problem. Gone. And if I check my S1, So 7 will not be there, right? It has gone. But same way, if I pass again S1 dot discard, okay, and pass 10 here, I know in my S1 there is no 10, so nothing will happen. Don't worry, your program will not crash. Okay, so you can use this way and check your S1. Your S1 is the way it is. Okay, so which is safer? Your discard is a safer way to use. Your discard is safer way, means your remove will do the same thing. Discard will remove, do the same thing. Just that discard is a safer removal. Means if element is not present, it will not crash your program. Okay, if element is not present, it will not crash your program. And if the element is present, in case of remove, then it will remove the program, it will remove the element. I'm repeating once again, if discard, I'm using the discard. If element is present, it will remove that element. If that element is not present, it will not do anything. But if you are I'm using remove, if the element is present, it will remove the element. If the element is not present, it will raise an error. Now the question actually people might think, sir, why then two functions have been devised? Why discard and why remove? When discard is the safer thing, okay? When the discard is safer, why we are even bothering? Why we created remove? When discard can safely handle, tell me everyone, this question should come to your mind or not immediately. Why two functions for the same? Tell me, this question is coming to your mind, not both are same thing, but why one safer, why one unsafer? Any idea, everyone? Can you think? Can you think? Please tell me. This question is coming to your mind or not? First of all, tell me this.
Yes, sir.
Right? Actually, reason is that intentionally we created a program like this. Sometime we want to capture. We want to capture. What we want to capture means that element actually is present in that or not. If that element is present in that or not, if it is not present, I intentionally want to raise an error. Actually, and these errors can also help us, trust me, with the help of exceptional handling. Okay, these errors that we are getting can be captured with the help of exception handling, and we can do something. For example, if he's not there, I intentionally use remove function, and the 10th element is not there. Then I want to do something else. Means I want to do something. If this error is raised, okay, then do something else. For those particular purpose, actually, this twin function means two functions have been designed. We want to capture that it is absent. I intentionally wanted to capture why it is absent. Okay, and we will see that I think within a day or two we will come to the exception handling, and you will see that these kind of errors will be helpful for you. You can capture those, and with the after capturing those, your program won't crash, and you can do something else if you are using exception handling. Right? So sometimes intentionally they create this way. If it is not present, I want to do something else. Okay, that's why the two functions are there. So let me move ahead with the next method. So three method we have seen: add, remove, discard. Similarly, there is a method known as update method. Several methods are there. Let me go one by one. There is an update method. So I have already set this one available. And suppose I want to further add some elements to this. Okay, so let me go here and I should mention s1 dot update. Okay, and within that I can pass any iterable. Any iterable I can pass. Okay, and the element of that iterable will be taken and it will be added to your set and will be added to your set. Suppose I'm adding here iterable is list. Okay, so list is a iterable, your tuple is a iterable, your string is a iterable, any iterable you can add. So for I add 5 comma 6 comma 7. Okay, so if I execute this, done. If I check my s1, can you see my set has been updated? So the element of my iterable has been added here. Okay, so element of my iterable has been added to my set, or I can say my set has been updated. Is it fine, everyone? Please tell me, is it okay?
Yes, sir.
Right? So this is the purpose. When we want to update our set, we can use this. And you can see the definition inside, no problem. See, update a set with a union of itself and others. Okay, even suppose I want to pass further elements, update. Suppose one more list I should take, or let me take another iterable, let's say Praveer. Okay, let me execute this. Okay, already 5, 6, 7 are there, no problem. Let me change them. Let me make 10, 12, and 7. Yeah, that's fine. Let me execute this. Done. And now let me check S1. Can you check, everyone? This 10 has been added. I think it should be there. Yes. Okay. 12 has been added. That has been taken here. And 7 already there. So duplicate was there. So it tends why intentionally only one will be kept, right? But it is an iterable. So every element of this has been taken and has been included in my set. I think it is okay, everyone. Fine. So you can pass multiple iterables if you want to pass inside. Okay. Fine, everyone. What is the purpose of the update? Okay. When we want to update our set. Okay. So now move ahead. Means we can use any iterable and you can pass inside. But the basic rule will remain same. Basic rule will remain same. Remember, it cannot have duplicate elements. It cannot have duplicate element. And can you see what is the order I'm getting right now? Can you see 10 is here, 12 is here, anywhere they are getting added. Doesn't matter. Okay. So move ahead now. Suppose I want to clear my set. Okay. I want to remove all the elements of my set. So again, we have a function known as clear. Okay. A method known as clear. If I go inside, see, remove all the elements from this set. Remove all the elements from this set. So if I execute this and check my S1, see what it is? It is an empty set. Nothing is there. It's an entire empty set, right? Similarly, let me move ahead and create one set. Suppose I'm creating a set 1, 2, 3, 4, 5, 6, and I use one more set, suppose S2, which is having elements 3, 4, 5, 7, 8, 9. Okay, so I have two sets available. Okay, so let me go ahead and move. Suppose now another method is S1 dot difference. Although we have seen that, but no issue, that we saw with the help of operator. Okay, we use S1 minus S2. Same thing is here, difference. Okay, what it does, go inside and read. See, returns the difference of two or more sets as a new set. Okay, returns the difference of two or more sets at the new set. Means what? Now read this. If all the elements that are in this set, but not the others. Okay, means here I can pass multiple sets if I want. So it will check, okay, and it will return only those elements. Understand everyone and read properly. That's what I'm saying. See, it returns, okay, it returns the difference of two or more set as a new set. And what it does, return all element from this set, which set they're talking about, on which you are applying this method, that is S1. Okay, so all the elements that are in this set, but not the others. Okay, but not the others. Okay, in that scenario, you can use a difference method. You can use a difference method. Let me take an example the same way we discussed yesterday. Suppose I created a set known as uh, suppose complete team. The name is team. Okay, in team we have few members: A, B, C, D, and E. Okay, so suppose there is a team. You announce the team. Okay, who will play the match? So these five people say, "Sir, we will play the match." Okay, and let me get a set of this. I intentionally created a list out of this. Yeah. Okay, so I created a set example. Okay, this is a set of the members who decided, okay, we will play. So we created a team. But what happened when the day one happened? Okay, only people who turned out are Mr. A and Mr. C. Okay, similarly, this is day one. On day two, what happened? Who turned out? Mr. A turned out. Okay, and Mr. E turned out, or Mr. D, anyone you can take. E turned out. Okay, something like this. So this was the day when the team was announced. So five people said, okay, sir, we will play. But on the day one, Mr. A came and Mr. C came. On the day two, Mr. A came and Mr. E came. Now I want to know, understand, I want to know who are the person, understand everyone, who are the person who didn't, who means the, who are the person who registered on the team, okay, who registered in the team, but actually they didn't appear on the day one and not even on the day two. Okay, they didn't appear in the day one nor in the day two. They said that we will play, okay, but neither they appeared on the day one and nor they appeared on the day two. So what we can use now, the difference method will helpful for you. Okay, I can pass here what, day one comma day two, right? If I execute this, okay, what I should get, everyone, A is present, right? C present, E present. So who are not present? B and D are not present. Means the members of this element who are not present in day one or in day 2 means who are not present in this set nor they are present in this set. Those members of this team who are not present in this set nor in this set, who are those? Those are Mr. B and Mr. D. So if I execute this, which one? Okay, sorry, I mentioned wrong. Team dot difference, right? Team dot difference, because I'm applying on this, so it will return me those elements of team which are not present in day 1 nor present in day 2. Okay, let me execute this. Can you check, everyone? Tell me, is it fine?
Yes, sir.
Okay, it should be clear what it is doing. But see, it is returning some value, so you can save it somewhere. Your original team is the way it is. Your original team is the way it was, right? A, B, C, D, E. Okay, so it is returning some value. You want to save it in some variable, so you can save it there. Okay, but similar to this, actually, we have one more function known as difference update. Okay, very much similar to this. Exactly means very much similar, exactly same. Only one difference is there, day 1 and day 2. Okay, what it will do, understand? It will give the members of team who are not present in day 1 nor present in day 2. Members of the team who are not present in day 1 nor present in day 2 means the members of this set who are not present in day 1 nor present in day 2. But at the same time, understand, they will update same information in your original team set. Okay, this information will be updated in original team set. Earlier, what was happening? Remember, your team was same. If you check this function I execute, but your team remains same. Team is unchanged, right? But if I execute this, right? If I execute this, this information will be updated in my original team. So now team will become only B and D. So if I execute this, okay, and check my team this time, can you check? Your original team has been updated. Okay, so what has been happening? Whatever difference will come, that difference will be updated in your team. So now your team will have only the difference element. So that's why the name is difference underscore update. Clear, everyone?
Yes, sir.
Okay, it should be clear. Now move ahead. Same way. We have what? Symmetric difference. Exactly same way we have symmetric difference. So suppose I pick two sets are there, S1 and S2. Very much similar. Nothing much difference. S1, this is my S1. And this is my S2. Can anybody recall what is the symmetric difference we discussed yesterday? If you can recall. Difference, can you see what it returns? Uncommon elements. Okay, what it returns? Uncommon elements between the sets. Okay, so suppose I have S1 and I have S2. So I come here, I mention S1 dot. You can use, as I mentioned, you can use operators or you can go with the functions. Anyway, it's your choice. Okay, S1 dot symmetric difference. Okay, and always read the definition. Returns the symmetric difference of two sets as a new set. Okay, returns the symmetric difference of two sets as a new set means what? Only uncommon elements. Only uncommon elements. So if I suppose I pass here S2. Okay, so check which elements of S1 and S2 are uncommon. Can you tell me, everyone, which are not common? Means the element of S1 which are not present in S2 and element of S2 which are not present in S1. Which are those?
Two.
One is also there. Yes, 1, 2. And then see, 1 and 2 are not there, right? Okay. 3, 4, 5
Six,
is
sir.
there. 3, 4,
Six.
5 is there. So 3, 4, 5 is there. 6 is not there. So 1, 2, and 6 from this first set. And
Second is
7, 8, 9. Right?
nine.
7, 8, 9. So if I execute this, see what I'm getting. Clear, everyone? So what it is uncommon
Yes.
element. Okay, exactly the same way we did with the help of operator. These are the methods, and exactly same way we have another function, very much similar, symmetric difference update. Okay, and now you can guess what it will do. Okay, this is returning a value, but your original S1 is remain unchanged. If I check here, my original S1 is the way it is. 1, 2, 3, 4, 5, 6, right? But if I execute difference update, then what is the result of a symmetric difference update? Okay, symmetric difference that will be updated inside my S1. So S1 will have the result of symmetric difference this time. So if I execute this, if I check my S1, it will have this result. Check here S1. Can you check everyone? Please tell me. Tell me everyone. Fine.
Yes, sir.
Okay. Similar to these, we have a few functions more. Let me create one more set. S2 is, yeah, S2 will remain same. S2 will remain same. S2 is the way it is. S2 is remain same. Okay. S2 will remain same. Okay. So we are applying on S1. That's why. Okay. Now let me come here and let me create few more sets so that you can understand. You will see the theory. Suppose I create a set S1. Okay. And which is having element 1, comma 2, comma 3, comma 4, and suppose 5, comma 6. Okay. And I create one more set S2, which is having element and only those elements which are part of this. Okay. Part of S1. Suppose I mention 2, comma 3. I execute this. Okay. So I come here and I mention here S2 dot, I press tab. Okay. And click on is subset. Okay. I mentioned is subset here. Is subset, right? So what is subset is doing? You know what is a subset and superset, everyone? Any idea what is subset and superset? If the elements of this set are coming from another set, okay, are coming from another set. See, understand this one is this 2 and 3 are coming from another set also. These are the part of this set, okay, but this set is a bigger set. This set is a bigger set, means it is having 2 and 3 as well as more element than this. So what will happen? This S2 will become subset of S1, but S1 will become superset of S2. Clear, everyone? Okay, this 2 and 3 means if we will, how will check this 2 and 3 are part of S1, but it is having other elements as well, right? 1, 2, 3, 4, 5, 6, right? So it is what? It is superset of this set. And it is what? A subset of this set, means few elements of this set has been taken in the S2. Okay, so if I check S2 is subset of S1, if I execute this, see what I'm getting. Yes, it is true. Clear, everyone? Please tell me, is it clear or not?
Clear, sir.
Right? Similarly, S1 is what? Superset. So you can mention S1. Just a second. Yeah. I can come here and I can mention S1 dot, okay, is superset of what? S2. Yes, it is. So it is having all the elements of S2 as well as other elements as well. Okay. So if I execute this, see, it is true. I hope it makes sense. Simple thing. I don't think so. There should be any issue in the same, everyone. Tell me, everyone, is it fine?
Yes, sir.
Right? It should be clear. Similarly, we have other methods as well. Let me finish those. Let me again come. And suppose there is a method known as S2. Okay. And there is method known as is disjoint. Okay. But see, please read properly, everyone. Return true if two sets have a null intersection, means they have no common element. If they have no common element, you want to check, okay, there are two sets. Are they having any common element? Question is this only. Are they having any common element? If yeah, if they are the common element, then return what? Example, false. If they are not any common element, returns true. Okay. For that purpose, this is disjoint. So suppose I mention S2 dot is disjoint with S1. So tell me, everyone, are there common element in S1 or S2? Yes or no? There are common elements available or not? There, yes,
Yes, sir.
they are there, right? So is disjoint? No, S2 is not disjoint from S1. They are having common elements, so it will return me false. Can you check? Because they are having common elements, right? But suppose I do something, I mention here S2 dot is disjoint, and I pass another set here. Suppose the set is 4, 5, 6. Okay, another set I passed here. So this set and this set will be compared. And we will check for the common element. So S2 is having 2 and 3. It is having 4, 5, 6. So there is no common elements. Now it will return what? True. Clear, everyone? Right? Okay. Similarly, if I come here, we have further method. If I say we have again S1 and S2, both the things are available. If I mention S1 dot intersection. Intersection means what? Remember, what is the intersection? Everyone? Intersection is for which purpose we use? Tell me, everyone. We discussed only. Yesterday only we discussed. What is intersection? In the set theory, common elements. Okay. If you want to find out the common element between the two sets, what will be that? That will be intersection. So if I mean S1 or intersection with S2, let me go inside and read. Returns the intersection of two set as a new set. Okay. And what it does, all elements that are in both sets. That are in both sets, I want to know. Okay, all the elements that are in both sets. So S1 is having 1, 2, 3, 4, 5, 6. S2 is having 2 and 3. Okay, so tell me, everyone, which are elements which are available in both the sets? Which elements are those? 2 and 3, right? 2 and 3. So it will return that. Okay, execute this, returning a new set which is having the common element. But your S1 and S2 are intact the way they were. They will not be changed because it is returning. So you can save it somewhere there, wherever you want to save. It's your choice. S2, they are intact. Okay. But again, the variant of S1 is what? Oh, sorry, intersection is what? If I come here and mention intersection update, this time what will happen? Again, they will return the common element. But that common element means it will return the set of the common element, but that will be updated in S1 this time. So S1 will be having only common element, that is 2 and 3. So if I execute this, okay, and check my S1 this time, can you see what S1 is having, everyone? So whenever you will find in set update means whatever result will come, that will become your whatever set you have mentioned here. Tell me, is it okay, everyone?
Yes, sir.
Right. Now let me come here and come again to the suppose S1 and press tab. So clear, we have seen copy. Actually, I'm intentionally halting because in every thing, whether we is study list, as the name itself saying, it is used to create a copy. But actually, I want to tell you an important concept known as shallow copy and deep copy. Actually, when I will use this function now, it will show you the definition. It returns a shallow copy of the set. So important term is this, shallow. Okay, so I want to give a proper emphasis, at least half an hour on the same thing, because once all your data structures are covered, okay, I want to give a special emphasis on this, the shallow copy. Okay, because same thing, suppose I come here and create a list, okay, or even directly use a list 1 comma 2 comma 3, and then I mention dot, okay, and I press a tab. Again, see, there is a method known as copy method. Okay, and if I read this definition again, what it is showing, uh, what happened, dot copy. Let me create this way. If it is not taking this way, 1 comma 2 comma 3. Okay, let me create this, and if I come here, press L dot copy, okay, and come here and read again, see, again it is showing returns a shallow copy of the list. Okay, that's why I'm intentionally halting this, because once your data structure are complete, I want to give at least half an hour on the same thing, shallow copy and the deep copy, because it is an important interview question. Very, very important interview question. They will ask you what do you mean by a shallow copy and the deep copy. Okay, for that purpose, I want to tell you very much in detail. That's why I'm halting for the same. Okay, so don't worry about the copy method. We'll discuss that in detail. Okay, so S1 dot difference we have seen, difference update we have seen, discard we have seen, intersection we have seen, intersection update we have seen, disjoint we have seen, superset we have seen, this pop we have not seen, right? This pop, otherwise this remove we have seen, symmetric difference we have seen, symmetric difference update we have seen, update we have seen, union we have not seen, and the pop we have not seen. So suppose I create here pop. Okay, so of course pop is used to what? Remove an element. Okay, so if I go here, see, remove and return an arbitrary set element. Okay, remove and return an arbitrary set element means if S1 is what right now S1 is having two elements, so it will remove any one element of its choice. You don't know. That's why it's rarely used. So because you don't know which element is going to come, so it will remove that element and return that element. Whenever something returns, you can save it in a variable. Okay, you can save that side. And remember, whenever something is returned, it returns this thing. So that means you can save that result inside a variable, which you can use for the further use. So if I execute this, okay, so it returned what? Two. But it might have written anything. Does not guarantee it. It will return two or three or false. Nobody knows. Okay. For example, what we are having in the S2, if I come here and execute, or let me convert this into a list into the set. Okay. So suppose I'm saying this is S. S is nothing but set of L. Okay. So S has been created. Let me check S. Okay. And now let me apply this pop method on the same. So what it returned? It returned one. So any arbitrary element it may return means remove and return. Now if I check my S, S will not have one. It will have only 2 and 3. So, okay, so it will remove any arbitrary element from your set and return that element, which you can save inside a variable. Okay, which you can save inside a variable. Very rarely used, but yeah, it should be known. Now come here, there is a function known as union. Okay, so if I mention here union, so name is saying it does union. Okay, so what we can do, return the union of sets as a new set. Okay, and what it does, all the elements that are in either set. Okay, all the elements in the either set. So right now in S, what we are having 2 and 3. I can pass here multiple sets. For example, I pass here 1, comma 2, comma 3. Okay, and then I pass here example 9, comma 10, comma 11. We can pass multiple. So what it will do, it will return what? Union of these. See what is the definition? Returns the union. So can anybody tell me? We know what is S is having. S is having 2 and 3. It is having 1, 2, and 3. It is having 9, 10, and 11. So what it will give me? The result will be union we discussed yesterday, remember? It will take all the elements of the set that you are mentioning. If you are using union operation, it will take all the elements of set 1, set 2, set 3. Okay. It means your all elements will be part of the result set, but without duplicates. So it will remove the duplicates. So what will be the answer, everyone? Only Varun is answering. Others, please tell me. Tell me, everyone. I said
1, 2, 3, 9, 10, 11.
yes, 1, 2, 3, 9, 10, 11. Very good. If I execute this, can you check, everyone? Right? I think you got an idea. Very good, very good, very good. Yeah, great. I think it should be okay, everyone. Now see, actually a variant of set is there, which is known as frozen set. Okay, a slight different variant of your set, which is a frozen set. And why we actually use, okay, when we will use a frozen set, remember, when we don't want to update, we don't want to update our set. When we don't want to update our set, then we can use frozen set. Remember, in normal set, what is the option? If we go to the S dot, we have an option available. What? Add. We can add the element to that, right? We have an option of what? Update. So we can update that set. Means we don't want to update. If suppose my requirement, no, I should not be able to update my set. I should not be able to update my set. If that is my requirement, then what you can use? You can use a frozen set. Very simple, right? So how can I create a frozen set? Let me create a set simple, or let me check if I have a set S. What is the S right now? S is 2 and 3, right? So how can I convert this set into a frozen set? I will just mention, suppose I'm giving a variable name F. F is equal to frozen set. Okay, frozen set. And within that, we can pass directly a set which you have created, or you can create a set here. It's your choice. Okay, so suppose I'm passing a S here. So you will get a new set which will be known as your frozen set. Done. Now if I come here and check print type of F. What is that? Frozen set. So new object has been created, which is of the which class? Frozen set class. And now we see the method. See, in the S means your set, normal set. How many methods are there? Huge number of methods are there, which you can observe here, right? But if I come here and use F, which is a frozen set, and press tab. Can you see how many methods are there? Are you seeing that add method, everyone here? Can you see the add method? Please tell me. Add is not there. Update is there. Not update is there. Difference update is there. No difference update is there. Symmetric difference update is there. No symmetric difference update is there. Intersection update is there. No intersection update is there. Can you observe, everyone? Right? So updation is not possible. That's why, see, in S, all the options were there. See, S dot. How many updation operation was there? Add was there. Difference update was there. Intersection update was there. Okay. Symmetric difference update was there. Even update was there. But in F, we don't have those. Any update option. Can you observe? Clear, everyone? That means your F will not change now. Your F will remain the way it is. You will not be able to add any element to this. You will not be able to update it by any means. Clear, everyone? What is the use case? Okay. So remember, this is what? This is a frozen set. Now you will not be able to update this. This is the purpose of frozen set. Is it okay? If it's fine, can I move ahead, everyone? Nobody's saying something. Others, please tell me. If you're not getting, then tell me. I'll explain again. No problem with that. Okay, fine.
Yes, sir. Yes, sir. Carry
Okay.
on.
Okay, fine. Okay. So next data type that or next data structure that we're going to use is dictionary this time. Okay, dictionary data type. And let me do one thing instead of that. Hash. Yeah. Okay, fine. Okay, dictionary. First of all, some people call it as a mapping data type as well. Mapping data type. Because here actually we map this thing to this thing, this string to this string. But basically it is what? It's a collection of key value pairs. It is a collection of key value pairs. Okay, so basically dictionary is a collection of key value pairs, as simple as that. Okay, it's a collection of key value pairs, the easiest way I'm telling you. Okay, key value pairs. So what is this? What do you mean by key value pair? See, how will I create a dictionary? I will mention D. Example, any variable name you can put. You will use curly braces. I think we have discussed once, but not in detail. So now we will discuss in detail. Okay, we will use this curly braces, and now we will mention first of all the keys. Okay, and what is the use case? Actually, these are used in a places. For example, I told you, you open a store. Okay, in our store you have suppose thousands of elements available, right? And what you want from that element, you want to know their price. Okay, what is the price of Fair and Lovely? What is the price of Fair and Handsome? What is the price of Dove? So what is the price of this falana dikana? Everything what we talk about, right? Very difficult. So what do you want to do? You just put their name and it give you the price list. You just type their name in the system, you press enter, and it gives you the price list. Very much like you are checking your university result, you are just entering your roll number there. So roll number is what? Key. Your roll number is your key. And the moment I press your enter, what will happen? The moment I might press my enter, your result will be displayed there. So what are those? Those are your values. What result you are seeing. Okay, so that's why we are having keys and values. Means I give you two analogies. One with the university result, you put your roll number. So roll number is what? Your key. The moment you press enter, what values you are getting, that is your value. Similarly, you are opening a store. In your store, you put a product name and you press enter. The moment the price came, the price is what? Your value. Okay, so two things you will have. You will have keys and values. And how will you mention? First of all, you will mention your keys here. Okay, you will mention your keys. Okay, and then you will, after colon, you will mention your values. For example, key 1, value 1. Okay, then again key 2, then value 2. Okay, again key 3 and value 3. But one very, very important property that you should keep in mind, this is the way you create some important property, right? What are those? Your keys that you are creating, okay, keys should be immutable. or keys are immutable. What you are saying that. Okay, keys are what? Immutable. You cannot change the keys. Immutable means which cannot be changed. So keys are immutable, but values are mutable. I can mention keys are immutable means you cannot change the keys, but you can change the values. Values are mutable. Okay, and normally we create our keys. Whenever we create a keys, remember, we create the keys to be immutable data types. And no 99% you will see them string. String is also immutable, right? String is also immutable. So 99% you will be seeing your keys with the help of string only, because string is also immutable data type. Okay, so remember, first of all, your keys are immutable. You cannot change these keys. Once created, you cannot change these keys. Okay, you cannot change these keys. If you want to change, no, you cannot change. Done, you cannot change. But this value of the corresponding key value pairs, yes, you can change that. That's why I mentioned keys are immutable and values are immutable. Okay, and that's the important things I mentioned. Keep keys to be immutable type. And mostly what you will find, mostly keys will be of the type string. Okay, mostly keys will be your of the type string. Okay, so I just told you one how to create a key. Suppose a dictionary I want to create. How can I create? Suppose I mention here d is equal to, okay, one way. I have a store. So in a store I have a mango, and mango's price is 50 rupees, like this, key and value. Okay, again I have one more product known as apple. Okay, and its price is 30 rupees. Okay, but right now I'm passing only one value. It is not mandatory that you pass one value. Not at all mandatory. Okay, I can do this thing. Suppose I have a key, this time known as physics marks. Okay, and this I am passing here a data structure known as list. Okay, which is having 1 comma 2 comma 3 comma 4 comma 5. Right, similarly means in values you can have anything. See, I again suppose here mention this time chemistry, and this time I'm passing for chemistry a string as a value. Right, similarly I'm using again a key is this time suppose maths. I'm just giving an example, right? And for this I'm passing a tuple, 10 comma 12 1 comma 20 comma 30. So in values you can have anything. Okay, let me execute this. Done, my dictionary has been created. So in values you can have anything. You have, see, integer here, you have integer here, here I created a list here, here I use a string here I use a tuple here. Everyone, so in your values section you can have anything, whatever you want to store. It's your choice, whatever you want to store. You can store individual numbers, individual alphabets, or string, or list, or tuples, whatever you want to save, you can use this. Okay, this is one way of creating the list. Key, value, key, value, key, value, key, value. Remember the colon. Okay, another way of creating the dictionary is this, which is easier actually. Suppose I want to create a new dictionary this time. So what I will do, instead of typing this in the codes and then within the that after putting the colon, I'm mentioning my values, right? Instead of that, what I'm going to do, I'm going to mention something like that. X is equal to 1. I use a parenthesis or I use a function, see, tick function. Very much like we have a set function, right? Everywhere we have a function, right? We have a string function, means str function. We had list function. We had tuple function. We have a set function. Same way we have a dict function. Okay. And this I'm passing this way. I want to say, suppose create a key value pair. So I mention here what mango equals to 50, comma, apple equals to 30. That's it. Okay. Execute. Your dictionary has been created. If you check, it's done. It's a dictionary only, right? So in the dict function, I can pass the values like this. Okay. And they will be automatically packed as a dictionary only now. First value will be become key. After equals becomes value. Again, after a comma, this first value becomes your key. This becomes your value. So this is another way of creating your dictionary. Okay. So two ways we just saw how can we create our dictionaries. Okay. Now how we will access the element of a dictionary. How to access the elements of dictionary. Very simple. The elements of dictionary are accessed by their keys. Okay, the elements of the dictionary are accessed by their keys. Okay, how? Suppose. So I think I created a dictionary access. Yeah, I think D. Okay, this is my D. Okay, and I want to get the price of the mango. So what I will do, I will put a D. Okay, I'll square bracket. I will mention my key. Okay, I will mention my key, and again in single quote or double quote, whatever you want to mention, just mention the key mango like this. Okay, I just mentioned the mango, and what I'm getting the corresponding value. Okay, so I just pass the key here, and after the passing the key here, I'm getting the corresponding value. Similarly, I want to access this element physics, no problem. D, and I have to this time mention physics. I will get this 1, 2, 3, 4, 5, which is nothing but a list. Okay, so the element of the list are accessed by their corresponding keys. Okay, you will pass in square bracket your keys, and it will return you the corresponding value. Okay, it will return you the corresponding value that you want to put, right? Now suppose your dictionary is created. Now you want to change this dictionary. Okay, you want to change the dictionary means again dictionary is mutable. Set was mutable because if we are able to add the element in that, right? Similarly, dictionary is also mutable, so you can add the elements of that, right? So what I'm going to do, I'm going to mention here the example. Okay, and I want to add a new element: physics, chemistry, math. We have added. Suppose I'm adding this time English. So same dictionary name. Just remember the name. What is the name? D. So just mention the name D, and now the key that you want to add. Okay, this is the key. So English. English is not there, so I added a new key there. Okay. D English equals to whatever value you want to pass is your choice now. Okay, for this particular key, what value you want to pass? Suppose I want to pass 100. Okay, I execute this. So this will be automatically added to my dictionary D. So let me check this. Can you check now? English has been added. Okay, so you want to add further element, you can easily add. Just take the dictionary name in the square bracket, put the new key. Okay, new key name, and in the after equals to put the corresponding value. It will add a new element, add the new element to the dictionary. Right now, suppose you want to change the value of a any particular key value pair. Okay, you want to change the value of any category. Suppose you entered 100. You thought, okay, 100 was a mistake. No, it should be changed. So what I can do, I can again use the same process. English, the key should be same, right? And I can mention here anything I want. Suppose I mention 73, 74, or I can mention anything. It's my choice. Not mandatory that earlier it was a single element. Now also it will have a single element. No, it's my choice. Suppose I put a tuple here, 73,67. Okay, so what it will do, it will update my dictionary, and this corresponding key will have this particular corresponding value. So if I execute, see earlier what is having, earlier it is having the value 100. If I execute this, done, and let me check my D again. See, your English has been updated. And by looking at this, can you tell me it is mutable or immutable, everyone? It is supporting item assignment, right? It is what? It is mutable. It is mutable, right? And what we did, we updated the values. Updated the value. Suppose I want to delete any particular combination. Okay. Now suppose I don't want to keep this physics anymore. I don't require this. Okay. It's not suiting my requirement. Or suppose in your store you don't have an apple now. You want to delete it from your dictionary. So what you can do? Very, very simple. You can use the keyword del that we earlier discussed as well. Del. And now here pass your dictionary name and the square bracket corresponding key. So suppose I want to remove physics. So I will pass the key of physics. Okay. Pass the key of the physics. So let me execute this. It is done. And now let me check D. There will be no physics anymore. Okay, this is what we did. We remove the element from the dictionary. We remove the element from the dictionary. Similarly, you want to check how many elements are there in my dictionary. Your dictionary might be quite long now. So how many key value pairs are there? How many key value pairs are there? So in every iterable, we use one function, right? That was a len function. Suppose I use a len function. I pass my string, which is an iterable. It telling me how many elements are there in this iterable, right? It told me. Similarly, instead of list, sorry, instead of string, I pass a list, suppose 1, comma 2, comma 3. So it will tell me how many elements are there in this iterable. 3 this time, right? Instead of list, I create a tuple. I pass a tuple inside 1, comma 2, comma 3. It will return me how many elements are there in this particular iterable again. 3, right? Instead of tuple, I pass here a set. Suppose 1, comma 3, comma 4, comma 5. Okay. So in every element that is iterable, what you are getting, see corresponding. Right? So len can be used anywhere. Okay. So similarly, I can use len on this dictionary. What is the dictionary? D. Check everyone. Is it fine? Please tell me. Right, everyone? So len function, same len function we are using everywhere, right? Whether it was a list or it was a tuple or it was a string or it was a set. Same way it is working with the dictionary as well. So actually you will not be able to change the keys. That's why actually it is immutable, Varun. You will not be able to change the key anyway. We don't have any option of changing the keys. That you mean by immutable. Okay. So remember, if you have a mango, so mango will be known by anything else, then tell me this thing only. I mean, the option is not there. Even option is not there. You cannot change that anyway. Okay, you cannot change. Your roll number will be your roll number only. Okay, if you change the roll number, example, by some way, what will happen? The roll number, entire roll number will change. Okay, Varun? So entire roll number will change, right? That means the main sense, right? So your remember keys are always immutable. You cannot change keys. Okay. Now you can do one thing. You can loop over your dictionaries. Looping over the dictionary. Okay. And let's check how can we do that. Come here. So I have a dictionary D. If I mention here for I in D, okay, and I print here I. Okay. So again, it's iterable. So we can iterate over this. We can loop over it. Okay. But it returns, remember, it will return only the keys. Okay. If I directly iterate over this for I in D, if I mention, it will iterate over this and it will return only keys. So if I execute this, I will get the corresponding key. See, mango, apple, chemistry, maths, English. What are those? Those are only keys. Okay. So we directly iterate over those. What are those? Those are actually your keys. Can you see everyone? So if I directly iterate over my dictionary D, it will give me what? In every iteration, the I will or the loop variable will have the corresponding what value? Corresponding key value. So how many elements we have? 1, 2, 3, 4, 5. So in first iteration, it will have one key value. In second iteration, will have second key value. In third iteration, will have third key value. In fourth iteration, will have fourth key value. In fifth iteration, will have fifth key value. That's what we are getting here. Mangle, Apo key, something like that. Right? But now suppose actually in the interview, they ask you a loop over the dictionary and give me the corresponding values, print the corresponding values. Getting the point, everyone? What is the question? Question is that loop over the dictionary and give me the corresponding values only. I don't want dictionary. Can we do that? Tell me. How do we access the element? How do we access the values? What is the proper process of accessing the values of a dictionary? I want to access this 50. How will I get this 50? I want to get this 50. How will I get this 50? Tell me, everyone. At least one or two people, at least tell me. How can I get this 50 value? Yes, yes, perfect. Means passing this key inside my D. We see that, right? D mango. It was giving me 50. Right or wrong, everyone? So same way, can't we use print? I know that this I will be what? The key only. That's why the keys are printing here. Can't I pass here D in a square bracket I? Right? If I execute this time, what I'm getting? Corresponding values. So logic will never change, right? Logic is same. We know that it will always be what? It will always be giving me, if I'm using for I in D, I am directly passing my dictionary here. Okay. Other methods are also there by the help of which directly you can access the values. Don't worry. But I'm actually, this is an interview question that asks you this way. Okay. Use your dictionary in the loop and tell me how can I get the values? They want to know how much basics you know. Okay. They want to know how much basics you know. So you mentioned for I and D here and print. And how do we access the element? We know that after mentioning my dictionary name in the square bracket, I will pass my what key value. And we know that it's a string. That's why directly we don't have to put the key, that single quote or double quote here. Directly it is giving me the corresponding values. Clear, everyone? Tell me how I'm getting the result. Is it fine? Others, please tell me. Nobody's saying something. What means?
Yes, sir.
Okay, fine. Okay. And within a day or two, your first task will be about to given, right? We're about to finish the basics of the Python. So some task will be given to you and I'll give you 2 days to complete that. Okay. 2 days will be given to you to complete that task. You can do that in 3 to 4 hours, not more than that. It will not take more than 3 to 4 hours, but you have to do that. Okay. Remember, in within barely a day or two, tomorrow or probably day after tomorrow, I'll give you that sheet. You have to solve that because you will be given at least 5 to 6 sheets to solve the problems. Okay. And as I told you, a program will not be like this, means do this, something little bit, not very complex. Honestly speaking, that will not be complex at all. Just conceptual it will be conceptual. How much learning you have done on the basis of that. Because you are learning, you are investing your time, you are investing your money. So you should learn in a way that if somebody asks me, do you know Python for the data science? You can say, yes, sir, confidently I know. I can answer those questions. Okay, so I'm ending for the day, everyone. See you tomorrow. Is it okay?
Thank you, sir.
Okay.
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 Thank you.
Okay. Bye bye.